In this video, we're going to complete a proof of the distance formula. The first thing you should do is change your zoom so that you can see this better. So click this button, make it 100%. Before you start your work, add your name to the title of the slides and share your work with me as an editor. And when you're done, you will turn the website link for your slides into Canvas. So let's get into the proof. For the distance formula, we want to show that the distance, which we're calling d, between the 2 points x1, y1, and the point x2, y2 is the following formula, which we have right here. D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. To prove this, the first thing we need is a right triangle containing our 2 points, x1, y1, and x2, y2. So here is that right triangle. We have this blue point here is x1, y1, and this red point here is x2, y2. Now, we have this right triangle, so we're going to name the sides of this right triangle. So I'm going to call this bottom leg side A, and I'm going to call this leg on the side B, that is side B, and the side of the triangle that is between my 2 points, of course, is D, because D is the distance between the 2 points, and that is what we are looking for. So the hypotenuse of this right triangle, which is the long side, is D. And we know from our proof of the slope formula that side A has a side length of x2 minus x1. We know that the distance of this side length is the distance between these 2 points, which is their difference, x2 minus x1. And the same goes for side B. From our proof of slope formula, we know that the distance between y2 and y1 on the y-axis here would actually be y2 minus y1. So we know that the side length of B is y2 minus y1. We don't actually know what the side length of D is. That's what we're going to solve for. But now we have the first thing that we need to complete this proof. So here we are again with our right triangle, and we know that side B is equal to y2 minus y1, whatever those values are, and side A is equal to x2 minus x1. And the reason we're speaking about these side lengths in terms of variables instead of numbers is because we want this formula to work for any 2 points. So we're going to use the variable names for those coordinate points. The second thing that we need is the Pythagorean theorem. And we're actually going to be proving this later, but the Pythagorean theorem says that in a right triangle with legs A and B and a hypotenuse of D, that A squared plus B squared equals D squared. And if you don't know what those words mean, the leg of a triangle is a side of a triangle that is not the longest side. So side A and side B are both legs, and the hypotenuse of a triangle is the longest side. So we know that side D is our longest side of the triangle. So we're going to use this theorem, and we're going to use the side lengths that we have from our right triangle from up here. So the first thing we're going to do is substitute in our values for A and B. So we see A and B appearing here in the Pythagorean theorem, but we know that we could change those values to the ones that we have up here. So instead of writing a squared, I'm going to write x2 minus x1 squared because x2 minus x1 is the same thing as a. And likewise, instead of writing b squared, I'm going to write y2 minus y1 squared because b is equal to y2 minus y1. And all of this is equal to d squared. So we have plugged in our values for a and b into the Pythagorean theorem. This, the last thing we need to do is solve for d by taking the square root of both sides. So if I take the square root of both sides, that would look like this. But we know that the square root of anything squared, that would undo that. If we take the square root of something that's being squared, then that does undo it. So this is just equal to d. The square root of d squared is equal to d. And now we have proven the distance formula. The distance between any 2 points, x1, y1, and x2, y2, is x2 minus x1 squared plus y2 minus y1 squared. When you finish this proof, make sure you turn the website link into Canvas and click submit.